All right, howdy everybody. We're just going to give it one more minute. It looks like as we started up the meeting, it looks like folks are sort of piling in now. So we'll just give it another 30 seconds or so before we kick things off. All right, guys. Thanks for joining another skill series brought to you by Utility Cloud, and I'm excited here to get this rolling. So in today's topic, we're going to be talking about water loss, aka non-revenue water, and basically we're going to be spending the next hour in this panel type format. We're going to keep it conversational. We have a couple slides that we will get through at some point, but this is meant to be, conversational. We have some polls for the audience where we're looking to get some of your interaction, and our plan really here is to address how to wrap your head around scoping your water loss problems, B, how you get your data in the right shape to help analyze the problem and isolate the issues, and then 3 or C, I couldn't remember if I was doing numbers or letters, but the point is, like, what do you do about it? How do you put together a plan and start and sort of isolating the problem and fixing it? So before we get going, I wanted to briefly introduce our panel here. We have Alongo, Derek, and Kate joining me here today. Guys, if you wouldn't mind, just if you could share maybe 30 minutes on yourself, background, company, and then we can get right into the content. Alongo, I'll put you on the spot.
Okay. Yeah, thank you, Dan. Thank you for inviting me. Appreciate this. So yeah, my name is Alongo Theber, founder and CEO of Near. I spent last 15 years in consulting. Engineering is my background, and also asset management. Worked for some of the big cities as an experienced civil engineer. What Near does is kind of a real-time intelligence, what's happening in the network, and also forecast what's going to happen in the network, and also provide predictive, asset management and help them, making proactive data-driven decisions. That's us, and we are based out of Kansas City. Thank you.
All right, Derek.
Sure. My name is Derek McLaurin. I'm the Director of Design and Strategy at MuniLink. MuniLink is a software as a service-based municipal software company. We do everything from utility billing to websites to public notification. So we do quite a few different things. Today I'm going to bring to the table an aspect of capturing your usage from a utility billing side.
Good deal. And Kate, last but not least.
Hi everyone, Kate Gasner here. I am Vice President at Water Systems Optimization, or WSO, and we are a niche consulting firm that focuses exclusively on supporting water utilities in their assessment and management of water losses. What that actually looks like is a lot of data support, understanding what data sources agencies have to work with to understand and deduce their water losses, and then some strategizing, planning, and sometimes implementation of work to recover water losses where appropriate.
Good, awesome. Well, yeah, great panel here. Again, we'll keep it conversational. I'm actually in the room with with founder and CTO and close friend Mark Moreau here as well. Camera situation, we usually have the owl that would pan back and forth, but not today. So anyways, guys, thanks again for joining us. The first question here for you guys is just why is this an important topic? Like, let's think about some of why should someone care about this in terms of the financial cost, the environmental cost, public perception, what have you. I don't want to lead the horse to water on that, but why is this such an important topic?
I'll start us off with sort of a big picture. Water loss is important in a couple ways. The most tangible ways are the ones that you just spoke to. So there are physical losses or leakage that occur in the system, and some volume of that is going to be unavoidable. It's the cost of doing business and overseeing and managing a big distribution system. But most systems throughout the country are leaking more than that sort of unavoidable baseline. And that's a product of the simple fact that it's out of sight, out of mind, and it's sort of a operational cost that you often don't interact with until it surfaces or until it gets in your face and becomes a bigger issue. Why we want to elevate that issue so that you're motivated to go seek out water losses and recover them is because it's an undue cost for your system. Very few systems are essentially leaking, and that's water that you have treated and transported, sometimes a fair ways, sometimes at great cost, that is not going to your customers, that is not getting paid for. So we have a fundamental inefficiency in water losses. And especially for folks like me, I'm in California, we've got big conservation targets, we're strapped for water in a lot of places. This is one of those first frontier volumes where instead of asking your customers or your ratepayers that revenue stream to reduce use, you want to go to your system and see where you can recover water that doesn't cut into your budget and revenue sources. The other piece of the puzzle outside of those physical savings and cost savings that I like to emphasize is that in the process of getting an understanding of your water losses, you do sort of a pulse check on your whole system's health. You have to look at your production sources really carefully. You have to look at your authorized consumption sources really carefully, your billing data, where MuniLink might come in. You have to look at your operations. You have to look at all of these elements to deduce this sort of mystery inefficiency. And the process in and of itself can be a really robust one to check in on, do you know enough about what's going on in your system? Do you have enough confidence in these critical data sources?
And yeah, so super helpful. I mean, Kate, you've probably seen it all. What is, when you say that most or many utilities are sort of beyond that unavoidable level, how bad have you seen it on a no names basis? And what is do you have any sort of ballpark way of estimating what's that costing the utility? And again, ballpark, what's the ROI of fixing the problem, in the next 2 years?
Oh, I wish I could give you straight answers on that. I will start with the most direct. The most direct estimate is estimating that volume of loss. Once you get that volume, you can start extrapolating costs and then compare those costs of loss to benefits of intervention or costs of implementation. But if we start with that sort of baseline volume, how much are we losing? It really varies. Such a sad answer, but in a place like California where I can see the data, it's one of the places that requires very standardized reporting of losses. So we have a good data set on what's going on in California. We have a typical system, that median, that middle point of bigger utilities in the state, losing about 25 gallons for every connection in their system every day of the year in leakage. So of course you extrapolate that value out and you get millions of gallons of leakage for any system. The gallons per connection per day is a way to normalize it, so you're not penalized for being a huge system, and it's a little bit more tangible of a metric, that gallons per connection per day is one of the better metrics that we like. You can use it to compare across utilities, and it just feels comparable to other conservation metrics that we engage with. That metric, gallons per connection per day, is an output of the AWWA software that I can speak to a little later. It's one of the basic tools that we use to assess water losses. And that metric is one of the focuses of a lot of regulation. They're gonna, in California at least, use that metric for performance targets going forward. How much leakage do you have in your system in that gallons per connection per day? To answer your question, Dan, that volume is the starting point. So for a typical agency, 25 gallons per connection per day, you know, that's not egregious. I've seen agencies with 50 gallons per connection per day. I've seen agencies pushing 100, 150 gallons per connection per day. Of course, reminder, that metric is a normalized one. It's not saying you literally have leakage at every connection at that rate. It's just a sense of sort of your average rate of leakage throughout the system. We like to see agencies pushing that 20 gallons per connection per day, but that's going to be where it's only going to be cost effective where agencies have expensive water or where water resources are tight. So that's the real trick of the question, is that water loss management is such a cost benefit game. Some agencies with really cheap water resources aren't going to have pressure to reduce them much further. Whereas out here in California, where a lot of our work is focused, there's a lot of pressure to reduce leakage and water losses given the expense of our water. So to answer, like, how much does it cost a utility? Oh man, it just depends. I know that's unsatisfying.
Yep, it's great. All right, so one thing I wanted, before we get into the next questions, I wanted to actually poll the audience here. A couple of just basic questions here. So the first one I'm going to launch right now. Hopefully you guys see this. It says, I could tell you how much water our utility, I can't see the end of it, is losing every year. So this is a good, well, anyways, I just want to sort of baseline here and see where we are in their journey. All right, and I'll provide some real-time commentary here. So it looks like 75% yes, 25% no. It's actually higher yes than I would have expected so far. All right, good deal. So we sort of finished, it's normalizing at around 70 to 75% yes, and then 27% no. I also wanted to launch another question, which is, what are the barriers to addressing water loss in your utility? So this is a multi-select question where you can select on multiple checkboxes. So lack of leadership buy-in, or you could think of that as like lack of pressure. Problem doesn't seem to be big enough. We don't have the tools in place to capture or really to get started. We just don't know where to start, or this is a known challenge that we are proactively seeking the answer to. I recognize there are probably some other examples here or reasons, responses, but these seem to be probably somewhat all-encompassing. This is good. Again, providing a little bit of real-time feedback. We're getting, again, more than I would have thought, 75% so far. This is a known challenge and something that we are proactively addressing. We do have, this is an interesting one, so 31%, we don't have the tools in place. So that's good. We'll get into some of that in sort of our next section, which will be great. And we just don't know where to start. Another good one. All right, so I'll close that down. I think this is, before we get in, we have some slides that we want to show. I think I wanted to start first though with, if you are just getting started, what is, like, if today, you know, you receive sort of the mandate or the pressure that we need to get a plan in place, where do you start? you start immediately on the data side? Do you engage a consultant right off the bat? And this is for all you guys. What's the very first thing that you should start thinking about? Maybe just some broad brushstrokes, and then walk us through sort of what that life cycle tends to look like.
With this sort of umbrella view, I'll jump in again, but pass it along here. You definitely engage a consultant, of course, Dan. Just kidding. So I am in the business of helping agencies with this process, but you absolutely can get started with your data, and that's where we recommend folks start. Water loss is tricky because it is largely unknown to you. The scale of the issue could be apparent to you, but the sweet spot of recovery is often the water that is unsurfaced or the leakage that has not yet come to your attention. So this is an issue that takes a little bit of activation energy, but the resources are freely available to you to get started and understand the scale of the problem. We like to use the AWWA or American Water Works Association's quote free water audit software. Software is a little bit of a stretch. It is a Excel spreadsheet that walks you through the process of a water balance, which I think we'll go through today. And that process really helps you define the system that you're talking about, your distribution system, and take stock of all of your production sources compared to all of your sources of withdrawal from distribution. And that simple comparison will get you into some sense of the scale of the issue. It gets a little bit more complicated from there because you don't want to confuse different types of water losses. We want to isolate leakage eventually, and sometimes that requires understanding how good our data is, whether we're being misled by any of our metered systems. But that spreadsheet gets you started and can get you an awareness of whether this is a drop everything and really invest resources in the problem, or let's monitor and improve our understanding of this issue as we go forward. That software and that water balance pursuit, which is a year assessment of your water losses, is my recommendation on where to start.
I'm going to just pick up there where Kate left off, and the common theme I think we've heard so far from Dan and Kate is data. You have to have data before you can do any type of analysis. So I'll speak to that real briefly from the utility billing side, because that's usually where I get involved with customers when they're talking about water loss. So on your utility billing side, you want to start out your program making sure that you have good data. And what I mean by good data is if you don't have the data, of course, you can't report on it. So you need to track usage. Whether you're billing for that usage or not, you should be tracking it. And a little bit later in the presentation, I'll sort of talk about tracking usage through your billing system that you may not even be billing for, because you want to do that as well. The other thing that you want to do is not only just having the data, you want to have the data at the correct level. A lot of times I'll go out to visit a customer and they'll say, we need to report usage by this area of our system. Well, if you don't have that set, if you don't have your data layer set up correctly in your database, you can track usage every time you bill your customers. You're not going to be able to report at that level. So again, the theme from the utility billing side is, as it is from every aspect here, I think, is good data. And we'll get into some of the key points later on when we bring up some of the slides.
Yeah.
Yeah, to add to Derek, I think NEAR kind of comes into the third picture. Like we take the data that, the billing data from the usage from the individual meters, we're able to put the data in the network, the entire network, the GIS network. And also we connect with the SCADA data to understanding the real time, what's happening in the network. I mean, the spreadsheet, software Kate mentioned is great. It's just a once a year document. But if you really wanted to solve this problem, this is a very dynamic system. It's changes, a lot of changes happening. So you wanted to understand like a very granular level of understanding your network to understand where the real losses are, because your SCADA minus your metering gives you the water loss, but you have to put that demand somewhere. So pinpointing that leak and understanding, what's happening in the network is the key. So NEAR, provide that kind of service, software as a service for that. So.
Good. So this is a good segue. I'm going to briefly share my screen. That hopefully you guys just want to confirm. Can you guys see the slide here? This should be. Kate and team, can you guys see this?
Yes, got it.
Okay, good. All right, so guys, I think that was a good transition. I actually want to take one step back, and then we'll take 2 steps forward. So the next slide will get into the specifics of how we want to serve up the data, how you guys, from a utility standpoint, want to prepare to collect the right information, all the way from your supply through your billed, unbilled, apparent loss, all that. I want Kate, if you wouldn't mind, this is a really helpful framework for understanding what non-revenue water is. So if you wouldn't mind, can you walk us through this, and then we'll make that transition on the next slide to how we actually capture the information within each of these buckets.
Great. So this is a helpful schematic that we often pull up. It's an interpretation of the AWWA's software method, wherein we are drawing equivalents across different volumes. We say, hey, thanks to conservation of mass, we know whatever we put into the system, it has to go somewhere. And our job as utility managers and stewards is to appreciate where it goes and do the best we can at tracking the data to indicate where it goes. Water supplied, that leftmost bar, represents 100% of the water we deal with that goes to distribution. And we'll talk about some specifics on getting that number right, because as you can tell from that number, we start deducing or detracting other volumes of known use to understand or infer water losses. So one of my big takeaways with presenting this is to emphasize that if any one of these volumes is wrong or harbors error, you are misled in your resulting impression or volumetric determination of water losses. So if your water supply meters are off, or if your data system is disorganized so that you can't get a good sense of what you supplied into the system for the year, you're sort of starting with a wonky baseline, and your understanding of real losses or leakage will also be wonky. So this is a dependency equation where every single input here impacts our understanding of water losses or leakage. We start with water supplied on the leftmost side of this graph, and we then start subtracting the known volumes of our system. And this is all an effort to deduce water volumes of known tracking history so that we can understand volumes that we don't track so well. So we start with what we do track well. Water supplied is all of your production, your well production, your treated water, any imported water that you purchase. You want to get a good handle on that. From that baseline volume, we start turning to resources like your billing data or records of unbilled use, even estimates of things like flows to waste or operational uses for repairs. All authorized use or use that is intentional gets into this authorized consumption bucket, and we want to determine whether that's billed or unbilled, whether it has a meter behind it or not. Once we do that big subtraction, which is it can be a more complicated comparison than it sounds like here, but that's it in essence, a supply minus consumption equation. And what you'll see left over towards the bottom half of this presentation is water losses. Now this graphic isn't to scale, so water losses is usually a pretty small percentage of the whole, but we do this to emphasize this sort of relative nature of water losses. We're taking water supplied, subtracting authorized consumption, and estimating what is water loss in our system. The last piece of the puzzle here that we break out is the two different types of water loss that we deal with. When you do that water supplied minus authorized consumption, you get a big volume of water that you haven't received revenue for, and you haven't intentionally delivered, like that unbilled consumption. But there are two very different volumes captured within that umbrella of water loss. A small portion usually of that volume, sometimes a small portion, a portion of that volume is metering error or some sort of systemic data handling issues. So you think you've accounted for all your authorized consumption, but there's water that has been delivered, you just haven't tracked it. And that can fall into this category of water loss. We distinguish that as apparent loss. That's meter error. Think of it mostly as meter error.
We've lost.
Technical difficulties. Can you hear me still?
Yeah, we're good. We got your back.
Okay, sorry. My desktop keeps like rebooting slightly. Okay, so we've got finally we've got real losses. So once you subtract those meter errors and take a stock of what your meters might be missing, you can then go isolate your real losses or physical losses from the system. So in summary, you go from left to right on this figure and you start subtracting known volumes to understand less and less familiar volumes.
Awesome.
I will get
This is
that on
what-
video one day.
Kate, that was really helpful. What is, this might be a very obvious question to you, but if you're just looking at sort of quantifying different parts of this, really in the third column, probably, what tends to be the longest pole in the tent in terms of just the absolute hardest to pin down?
Ooh, great question. We usually see that folks have a good sense of their water supplied. That's a piece that is often regulatorily required to report in some degree. Maybe you're in an adjudicated groundwater basin. Maybe you're in California where monthly reporting on your production is also required. That piece is often pretty sturdy, and SCADA plays a big role in that. So we've got relatively fine resolution automated data. Authorized consumption, another usually pretty good source. The question there, as Derek alluded to, is how you query this huge database and how you make sure you're getting the right number from an array of a lot of numbers. We usually have the hardest time pinning down apparent losses. So once you have your water loss figure, this question of what you're missing at the meter, if I deliver Derek at his service connection, if he uses 10 gallons on a certain day, but his meter's only 90% accurate, me as a water utility will only see 9 gallons, and that's what I file as authorized consumption. So there's that 1 gallon that I'm missing, and that is a hard piece to figure out because you're not going to test every meter in your system, but you want to get a sense of the accuracy of these really critical instruments. So I would say apparent losses is very difficult to pin down and often the area that we're doing the most guesstimating on.
Kate, this is Mark speaking. Apparent water losses, does that also include some of the data that's not tracked in either of the systems already mentioned, like SCADA or the billing system? There's a third of wasted water, if you will, intentionally wasted water around flushing of hydrants and hydrant systems, antifreeze endpoints that spray water.
Great question.
There's all these examples, fires, the fire department, completely different departments consuming water that's unmetered. What are some of the ways that you can capture that data? Obviously, utility cloud's a great forum for that, but how does that account into the sources and the reconciliation?
Yeah, so we want to account for that as carefully as possible, and we do that in the unbilled consumption arena. There are two subcategories of the unbilled consumption category. There's unbilled unmetered volumes. That's where your operational uses, your firefighting comes in. And even if they are wasteful or maybe not that carefully tracked, in most cases they're not carefully tracked, they are intentional uses. And we want to distinguish between an intentional quote, authorized use of water from this unintentional leaking infrastructure. So we do that by categorizing all those uses, usually as guesstimated volumes in the unbilled consumption. And this is where error comes into play, right? Because it's really hard to track down how much water your fire department uses or how much your repair crews use to flush the new mains in your system. So unbilled consumption, that box has a pretty big error margin on it, and that can affect our understanding of what's left over as the real leakage problem. So the more you can quantify those unbilled consumption uses, the more you can put numbers to those operational uses and see where you might even be able to squeeze those a little to reduce those unbilled uses. That the better quantified values we have there, the better our appreciation of the actual leakage.
So it's important to establish data collection practices outside of the SCADA or meter reading.
Absolutely. When we work with agencies, we're doing a lot of sleuthing and a lot of asking questions about what are we missing in our biggest sources of data? Because it's true that SCADA and your billing system are going to be the heaviest hitters. They're going to do the biggest lifts on these sources of data for water supplied and authorized consumption. But inevitably, there are random spreadsheets or someone's memory of the year that has to come into play so that you're not underestimating where some of this water is going.
Awesome. So that's a great segue. I wanted to move on to this slide, which I think we'll get some good participation on. So for folks on the line, I basically in advance of this said, hey Kate, if when you walk into an engagement, what if you could design the ideal way in which the utility served up data to you in terms of how they're structuring and capturing their data, what would that look like? And Kate put this slide together, which I thought was incredibly helpful. I think the reality is obviously, WSO walks into an engagement and the data they get is the data that has been established for 15 years or the last 5 years or whatever it may be. But this is, I think, a really helpful framework to think about, if you're trying to get your data in the right shape to help both quantify and then start to resolve your non-revenue water problem. These are the types of data points that you want to be capturing across different points in that last graphic there. So on I guess, Kate, if you wouldn't mind, just talk us through, let's start on the left-hand side with the water supplied. I think walk us through briefly, just what are those data elements? What are the best ways of capturing those? And maybe what are some of the biggest snags that you guys run into that prevent clean data from coming your way?
Great. So I'll try to do this briefly, maybe just to preserve some time for questions that are coming in, but I'll let this be a teaser into the world of water loss data. What we see here above the line is water that's important for that water audit. And we call that a top-down water balance because we're deducing water losses. We're saying, what are the volumes that we know about our system, water supply, billing, et cetera, and then how do we describe water losses the best we can from those known data sources? That bottom element is a bottom-up assessment where you're going to the source of what you do know about leakage, and you're saying, okay, how much have we repaired this year? So these are two sort of different strategies to get a handle on your leakage. So far, we've been talking most about the upper tier, which is a, quote, top-down assessment, where we're inferring water loss. For water supplied, again, you're really interested in what hits distribution. So this is important for agencies who own treatment plants or own operational infrastructure that's sort of just beyond distribution, pressurized flow. For folks that have tracking of raw water infrastructure or folks that operate treatment plants, it's important for you to decide where your tracking of supply starts. Because if you have redundant meters, a raw water into your treatment plant, and then a finished water meter outside your treatment plant, and then some complicated backwash scenarios, you're going to have to decide where the system starts. And we want to make sure that it starts as close to distribution as possible so that we're describing losses on distribution. So that's the first thing to do. And we highly recommend you bring out maps, you talk to treatment plant operators, and you decide what is the list of production meters that is comprehensive of what goes into our distribution system, but not redundant, and captures our best estimate of this supply into distribution. That can be a lot, especially for bigger systems. That can be a big exercise. But for smaller systems, maybe it's like you isolate that one finished water meter that is going to be the supply instrument. Don't forget your import and export meters also count on distribution total flow. It's also important on your production side of things not to just trust your query from SCADA right off the bat. We often find that SCADA has gaps despite its capacities. Sometimes connections are broken, so you want to look for anomalous data in your year's worth of supply. Was there a period of time where no flow or suspiciously low or high flow occurred? Any issues in your data, again, will show up in your estimation of leakage. So we want to make sure it's as accurate as possible up front.
So is that, Kay, does that tend to be the most challenging piece of calculating your water supply? The sort of dirty data, the exceptional, anomalous SCADA data? Is that?
Yeah, it's grappling with those anecdotes from treatment plant operators, for example, that say, oh, yeah, that's the best data that we have on finished water that goes to distribution, but man, we don't trust that meter. Or it was really wonky last fall, or yeah, it kind of deadlined on low flows. You know, it's those kinds of stories that suddenly you're like, okay, that is our best meter, and for a majority of the year we do have good data, but if we're missing information, then we will underestimate our sense of leakage. So it's that qualification process that you want to make sure to go through.
Yeah, and when you do, I guess, when you do run into that situation where, I guess that's where the statistical work that you guys do comes into play. You can basically triage how you want to adjudicate that gap or that overstatement or whatever it is. You have to sort of apply the right estimation technique to figure out how to smooth that out, basically.
A lot of our work is both very technical and somewhat emotional on grappling with uncertainty. Yes, this is the data we have. Yes, this is the best information we have, but how do we deal with these gaps?
Yeah, it's great. All right, awesome. Let's move over to authorized consumption. So this is maybe where Derek, this is maybe your area of expertise here too. On authorized consumption, this is accounting for all authorized withdrawals from the distribution network. What's sort of important here?
Important, especially from the billing side, is I see a lot of customers that will not meter every property. If it's a fire department or a public park or a library where they're giving them the water, they don't meter those, and they should be. Or on the flip side of that, they'll actually meter. I'll use the fire department as an example. They'll meter the fire station's water, but they won't collect that because they're not going to bill the fire department. And in essence, you should be number one, you should be metering all of your connections, and you should be tracking the usage for all of those connections, whether you're going to bill that usage or not. And just to back up a little bit, something that Kate was talking about with authorized consumption and the fire department's using a lot of water from fire hydrants and so forth. I can relate to that very well because another hat that I wear is I've been a volunteer fire chief for many years. So I'm a guilty party. I go out all the time and flow hydrants, whether it be for structure fires or training or whatever. And the sad part about it is fire departments know how much water they flowed. All of the new fire apparatus have flow meters. In fact, when we come back from every structure fire, we always just, out of curiosity, how much water did we flow on that alarm? So we know that number. We just don't report it to the water department. So that's something that water companies should be talking to their fire departments to get those numbers, because they probably have them.
Great. And then, Kate, from your side, any any other sort of snags or issues that you tend to run into here? It would be a good call out.
Yeah, so I think, and Derek's probably super familiar with this, but usually billing systems are, they've got one goal in mind, which is to get bills to their customers and receive that revenue. And then suddenly we turn to this big database for a volumetric referendum for the year or for the month or for the day. And that pivot can be kind of hard for these databases, unless you set them up intentionally with good queries and a good understanding of how do I sort of shave off the noise of financials and get to a volumetric summary. And to do that, a lot of systems are well equipped, but you just want to do that very sort of intentionally, very self-consciously, that you're not double counting certain categories or you're not overlooking others, these unbilled values that sometimes get less attention because they're not generating revenue, understandably. So this focus on volume reporting in the billing database as opposed to bill generation can be a bit of a shift for folks, and is often something that you have to have seriously detailed conversations with your billing folks about to make sure that you're not accounting for any adjustments for any billing complaints, that you're not getting any as few estimates as possible in these volumetric summaries, that you're really going to the meter reads at their basic reporting.
Great. And let's go over, so let's transition over to the infrastructure data side. So Kate, you had put in here up-to-date summaries of total pipe mileage, total service connection, system-wide pressure information. What is that? Just walk us through a little bit more, like in what format is that data typically best served up? Is that something that lives in best served up through like just standard GIS, or what? Like talk to us about what great looks like there.
Yeah, great definitely looks like GIS, ideally. Anytime you have geo-referenced data, it prepares you for implementation. Oftentimes we're working with summary data at the very first start so that we can calibrate something like the water balance or the AWWA software for like, what kind of system are we dealing with here? What's the scale and size of the system? But total pipe mileage and total service connection counts, those are the most general summaries of what's going on in your system. The more high resolution data you have, the better you will be equipped to say, okay, this portion of our system needs the most help. Let's isolate this area for intervention. Or, wow, these types of service connections are presenting the most failures. So let's go and isolate, these types or sizes or materials of service connections. So this is really just the start, but the better information you have on material, age, type of infrastructure, the better you'll be. And if that's geolocated, you're in good shape.
And what do you do? Like, so let's say that you do, in a perfect world, this is all easily mapped out in a geocentric way, and you understand the material and all this other data here. Like, what do you then? How do you act on that data? Like, what does that help? Provide you clues, or like, how do you then take the next step with that data available?
Yeah, great question. So that's usually where we start blending these two tiers, where we say, okay, let's look to the repair records and see if there are any trends on which types of infrastructure are failing most frequently. And then you at least have some cues as to what your problem children are in the system. Sometimes cues don't surface though, so that level of texture on your infrastructure isn't that helpful. That infrastructure detail will inevitably be helpful when you start doing more proactive work though. So leak repair records as far as we normally engage with them, are repair records for failures, for leaks in the system that surface or require attention. And these are the things that that either make the news or make a customer unhappy in some way, so you're obliged to go respond. There's a lot of leakage that doesn't make the news and doesn't affect the operations of your system and is ongoing in your system. And that's the stuff that we encourage folks to go proactively find. If you do a proactive leak detection survey, the most basic form of this is a manual leak detection survey where you're walking the system and acoustically sounding for leaks. You'll get a wealth of information on what those unsurfaced leakage points are. And that's where the infrastructure data and which pieces of the puzzle are hiding leakage from you becomes really valuable.
Yeah. To quickly, Kate mentioned it usually, like when the background leaks, it's leaking for some time. It usually takes 5 years or even more to surface. So when the customer make a complaint, it's probably leaking for 5 years or maybe more, depending on what the infrastructure failure is. So yeah, that's a great information. So.
And let's just because we're actually we're in our last 10 minutes here. I want to make sure we get to meter accuracy and then leak repair records. On meter accuracy, Kate, you had flagged some tests here. What's, again, maybe just to cut to the chase, like what is most useful and what's most difficult to capture? Where do you see the most struggles?
This is an area where we usually don't see very good information. So agencies sometimes test their meters in response to complaints on high bills or customer complaints, or maybe they're in the process of evaluating new metering infrastructure, so do want a sense of their current meter population. But we encourage folks where possible to get meter accuracy information. The small meters are most difficult because there's so many of them in your systems that it's required of you to sort of randomly pulse check your meters, which can be a big effort. That's the ideal case where you're sort of pop quizzing certain meters out in the field around how does this typical meter look in terms of its accuracy. Large meters, we highly encourage folks to test. They are very special instruments in your system, and because they are large and customers and see a lot of volume, any inaccuracy on large meter customers is going to have a big revenue repercussion. So we really encourage folks to start with those large meters and get a sense of how well they're doing. It usually is cost effective to visit those large meters, of course, depending on your price of water and depending on how much volume they see, but it's usually cost effective to see those meters tested at least once a year. It's a big project, but it can really pay back if you catch inaccuracy early. Small meter testing is a program that we sort of have to make a pitch for depending on what the agency's up against in terms of meter age and future investments. The value of understanding meter accuracy is that it better informs your leakage. If you have a lot of meter inaccuracy, if your meters aren't doing well, that cuts into this assessment of leakage volume. So it's this mass balance game that becomes important in this defining where your problems are puzzle.
So if your meter accuracy is poor, it would strike me that from your side, you'll have to perform more. You'll have to basically make more assumptions from a statistical point of view to inform the right action versus, yeah.
Exactly. And sometimes we say, hey, we don't know enough about your meter inaccuracy, so this leakage estimate has way more uncertainty than we're comfortable with. So before you go do that leak detection survey, before we guarantee you these savings in proactive work, let's study your meters. It'll be a good investment in isolating the problem, and then we'll feel more confident in pursuing the right issue.
Yeah, that makes a lot of sense. And so I want to hit leak repair records lastly, and we can do this fairly quickly. So this is obviously where one of the areas that we would support in. But what is, of course, like this data is all important to collect. To what end? I think, like, what's the most impactful data point that you guys can action? You mentioned earlier, you understand where particular infrastructure is failing. Is that the most informative piece of, the most informative clue, if you will, or are there other ones as well?
In terms of leak repair records, the best information is going to be break frequency. And to get a good break frequency, you need a comprehensive count of how many breaks occur, failures occur. I try to use the word failure to capture all terms of leakage and breakage in a system, because sometimes agencies vary in their terminology, but all failures. If an infrastructure piece breaks and there is leakage as a result, we want a record of that, because the frequency of that leakage can be a critical distinction in which type of intervention you take. If you have a lot of small breaks, that might define how you intervene versus a couple big breaks. So that break frequency is the thing that I usually emphasize. And that doesn't require a ton of detail. It just requires that you are documenting each instance of leakage pretty carefully.
Yeah, good. And so I have a couple like overarching questions here. You mentioned, so let's sort of span the gamut here. So on water supply, this is where you're utilizing your SCADA information with, obviously you don't take that for what it is, but you have to draw some conclusions from that. Your authorized consumption, you're largely relying on billing data infrastructure. We talked about there are a number of different ways to serve up that data, ideally in a GIS format. Your leak repair records, that's really coming from your work order management system. What do you see? You mentioned meter accuracy as the one where you usually get kind of the worst data. Two questions for you. One, are there any other areas where you see a continuous deficiency, or one that would be sort of a continuous like deal breaker in the effectiveness or the efficacy of the study?
Yeah, so that's really tough. I would say sometimes billing databases have fatal flaws. If you have very infrequent insight, if you're only reading your meters quarterly or every other month, that can really throw off how the volumes align. So that can be a big issue in billing assessments. And then on the flip side, leak repair records are often done depending on the agency and depending on your resources. We've dealt with agencies who dealt with a whiteboard, a very ephemeral way to capture your leakage, but that was their system of reporting leakage, and deploying field crews was a whiteboard, and they had no real record of what happened over the course of the year because they were just in repair mode, in real time, which made sense for their resource management of leakage crews, but didn't help us in a reflection on what happened over the course of the year. So I would say those are two other sort of holes. The resolution of the billing data that we get as compared to supply, and then the comprehensive nature of the leak repair records.
And is there ever, this is probably a really hard question and probably an unfair one, but are there ever situations where if, for instance, if you had no leak repair records or it's hard to imagine this scenario would play out, but are there ever any non-starters, like where you guys can't actually perform your study because of lack of information, or is it there's always enough to at least size the problem and develop some sort of plan? I guess is there ever that case where you just can't do the work?
Yeah, if you have a lot of unmetered supply that goes into distribution without any instrumentation on flow, that's a hard place to start, and we would have to work from the ground up on our leak repair records, because the water balance really depends on that assessment of supply into distribution. That'd be a hard place to start. Also, if you have a majority of unmetered customers and haven't done studies on typical use, that would also be a hard place to start. Mostly because that introduces such a wide margin of error on these two big volumes that you just don't know whether you're getting insightful, actionable results at the end of the water balance. So if you're in either of those places, you've got to refine those big volumes of flow before, and you could still assess leakage and you could still assess your water losses. It just have to be qualified, sometimes up to 100, 200% of that volume because of those big unknowns.
Sure. Awesome. Well, guys, I expected that we would have a little bit more time for question and whatnot, but we're right up on the hour. So I wanted, just for folks on the line, a couple of things. One is that this is going to be recorded and sent out as a follow-up automatically. Certainly, we'll also send out some materials to get in touch with Alongo, Derek, Kate, or us, should you want to hear more. But really, again, for all you guys on the panel, just want to say thank you again. A really fun time getting together and talking through the subject. So really appreciate it. And again, as a follow-up to the folks on the phone, we'll be sending out that follow-on along with the survey to hear from you how helpful this was. So again, really appreciate it to all you guys, and really thank you for the time.
Thank you.
Thanks, Tim.
Bye all.
Thanks, guys. See ya.